23.5. So if you consider, if you travel back here, the sun is neither towards the sun nor towards the away, neither away nor towards, because it's in this direction, right? So the effective angle is 0 degree. So that means there is no partiality when the Earth is here at 90 degrees. That is this thing is March and September. And I already discussed, March and September the effective angle of tilt is 0, because the Earth is neither towards nor away from the sun, and due to which the overhead sun will be at exactly the equator. So this 23.5 degree actually varies in this graph. If you make a graph, it's simply a cosine graph. So it's like this, 0 degrees, then it goes to minus 23.5, and then it comes 0 again, and it comes, so this is 23.5 plus 23.5 degree declination, and this is June 21st. This 0 degree is nothing but December 21st, and this is minus 23.5. This is sorry, this was not December, this is September, and this is December, and this is March, and it comes again same thing, June. So the cycle repeats every 365 days. You got it? So just if you are good in trigonometry and converting that 365 days into 360 degrees, you will be able to calculate the effective declination throughout the seasons, throughout every month. So let me rub this out. I wish you had some question and I was there to answer you spontaneously, but unfortunately it's not live. Now we have discussed the season. Yeah, so let me consider, let me then elaborate on the season thing. Consider June. Alright, now to make this class slightly shorter so that you can learn many things in a smaller amount of time, I would like to tilt the Earth's surface just 21.5 degrees, which is on July 15th, I think. Yeah, so on the July 15th, basically this is the separation. This is, sorry, let me make it more elaborate. So I'm just tilting 21.5 degrees. Alright, so this is the effective declination 25 degree on July 15th. So this is close to 23.5. Alright, so this is the effective declination on 16th of July, and at that point where the straight line, that is this line, is coming here, this is the sun space is overhead at this location, and this is nothing but Makkah. So I'm just to make you remember, I can just make a Makkah here right now. Alright, so this is the Makkah here, and the sun rays are coming like this. Yeah, so this is the Makkah, sun rays exactly overhead over the Makkah. At that point of time, at that particular date, we are determining the Qibla direction for all other locations. Wherever they witness the sun, that direction will be the Qibla direction for that location. Alright, now this is the overhead sun, and the person is standing like this. So everything is overhead, it's 100% sure, and this is 21.5 degree north, latitude, and this is equator, 0 degrees. Okay. Now at the same time I would also I did not mention about the difference, why the day is sometimes big and day is sometimes smaller. Now I will determine so corresponding. If you see, this line is the separation line for the day and the night. That means this point, the sun is rotating like this, see. Alright, earth is rotating like this. Alright, so this earth is coming here, coming here, coming here, and then going here, right? So that means when it's already 12 noon, this point of earth, this location is already traveled around 1 or 2 hours. So this might be some India. We know India is east of Saudi Arabia, and if it is 12 noon in Saudi Arabia, it will be around 2 p.m. here, right? It will be 2 p.m. here. And if you go further here, further here, it will be further east. So if you go further, maybe it will be Japan, even further east. Okay, and then comes the extreme here. And now if you consider America will be on the west side, because they are still witnessing the morning hours. So this is the noon, and they are still here. So they have to come here, right? They have finally to come here. So they are at this location, or maybe this location. This is America. This one. This is America, and they have to yet to travel around 4-5 hours before they return the noon time. And after the noon time, they have to go for. So this is the sunset. This is sunset, and this location is sunrise. Sunrise, rise, then noon, and sunset, and this is midnight. All right. So this is all about this thing. Now coming to the day, the difference of the day and the night. If you see, if you see this, let me slightly rub this out. Yeah, if you see, this length of the line is greater than this line, right? And that is because the axis line is separate from the separation line of the day and the night. So because of this, the day is bigger, because this is all represent day. As I told you, this line separates the day and the night, and the day is far bigger than the night. You got it? But for the equator, it doesn't matter whether you are because here there is hardly any difference between these two lines, that is the axis line and the bifurcation line, separation line. So the day is always equal to the day night. So irrespective of the tilt of the earth, the length of the day will always be equal to the night, but it reduces or increases while you go further from the equator. Now consider the case of the southern hemisphere. So consider this thing. Okay, now I'm making a parallel. All right, so see, this is the amount of day, and this is the amount of night. You can see the difference, right? Right, so you can see very well the difference between the. So if you can also project it down, and let me project it